can be addressed using a pointer. Similarly, 2D array is also possible for us to address with a pointer. So in the past lecture, we have, I'm sharing a screen. I hope it is visible. In the past lecture, we have seen this structure where a 1D array is pointed with the help of a pointer. And with the help of pointer only, we are trying to access the elements of that array. Through this program, we have done that. So few things which just I'll try to recall you people that here in this program there are two arrays, two pointers. One is an integer pointer, another is an array pointer. So the clear difference between these two can be seen here. So integer pointer and an array pointer. To array pointer, the complete size of that array is also assigned. There is another integer array. Now when I say P is equal to ARR, okay, ARR is nothing but the address. ARR is nothing but the address. So it can be stored into P, but P will point to only one element of it. It will point to only one integer. Whereas in this case, it is going to point to the whole block of array. Okay, whole array. Okay, so if it is having 5 elements, then it will be pointing to a block of 10 elements. Whereas P is pointing to the block of one integer only one member of the, because P is an integer pointer and PTR is an array pointer. So here only we are defining that PTR is going to point to a block of 5 integers, which is mentioned by this size, and here it is going to point to only an integer. Okay, so as we are assigning the same to both the cases, this will point to the whole array and this will point to only one element, that is 0 element. And if I'm incrementing, so remember this, just try to recall this whatever we discussed in the past lecture. If I am incrementing PTR, or sorry, I am incrementing a pointer variable, it will be incremented by the total number of bytes to which it is pointing. So P is pointing to for a block of 4 bytes, so it will be incremented from 100 to 104. And PTR is actually pointing to the whole block of 5 integers, then this will be changing from 100 to 120. So actually PTR is pointing to a block of 20 bytes. P is pointing to the block of only 4 bytes, that is one integer. So this difference you be very clear, and this logic only we are going to use it in further programming. And this also exercise we have seen how the size of it will be prompted. So size of any pointer variable will be the size of the address that machine is pointing. Let us say that the size of the address or the address pointed by that machine is of 8 bytes, then size of that pointer variable will be 8 bytes. Okay, because it's an address. So that pointer may be a float pointer, a character pointer, or an integer pointer, or an array pointer, whatever may be the type of pointer. Ultimately, it is going to hold an address, and that address will be of 8 bytes. So size of every pointer variable will be always 8 bytes. So here you can see, in case of size of P, which is an integer pointer, and size of PTR, which is a array pointer, both the cases it is going to return 8. Assuming that a machine is taking address of 8 bytes. If it is taking of 4 bytes, it will be 4. If it is addressing 16 bytes, then it will be 16. Okay. So this way, and of course, value at P is an integer, so its size will be of integer, and value at PTR or pointer is PTR is pointing to an array, so the size will be of. So this will be 4 and this will be 20. It's just a repetition I am doing, because with this logic we are going to continue with the discussion of array 2D array. Okay. Coming to this discussion of today's class, that is pointed to a 2D array. How a 2D array is defined? 2D array is defined in this way. Okay, so This says that there is an array with 3 rows and 4 columns. So in total, it is going to hold 12 elements. First 4, second row, and third row. So row 1, 1, 2, 3, 4, row 2, and row 3. So this is the way we are looking at an array. We are looking at an array, right? Looking at a 2D array. Now I'll repeat one thing about a 2D array is, or array is a group of similar elements. 2D array is a group of similar arrays. So 2D array is an array of arrays. So in this case, the 2D array, this 2D array is an array of arrays of integers. Right? This is can be clear with this. So this is one array, this is second array, and this is the third array. What I can say is row 1 is the first member of, can I say that, is it A of 0? ARR of 0, I am using A of 0. Can I say this as A of 1? And can I say this as A of? So A of 0, A of 1, or A of 2 are actually pointing to, or are going to represent the first element of the array. First element of the array. So what is the first element of the array? Is row 1. This row, it itself is an array, but it is the first element of a 2D array. And what is the first element of this 1D array? It is 1. Okay. So this this way I can consider this as a array of arrays where each row will be a 1D array in itself. Other way around, what I can take is I can consider this also as another form of same array. Can I say that this has the 0th array, this has the first array, this has the second array, this has the third array. Okay, I can say that this as A of 0 now. This is also possible. This is A of 3. So I can consider this 2D array as a group of rows or group of columns. Both way it is possible. Both way it is possible. So what is the difference between these two? This is just a representation difference. The way we are trying to store the values in an array is our option, and we can store either row wise or we can store either column wise. So whenever we store it row wise, it is called as row major. Remember this word. It will be called as row major. And if I'm storing it as column wise, the way it is done just now, right now in the example, it will be a column major. Okay. So what we do in this case, when we talk about row major, we will arrange the elements row wise. So first row will be your first element of a 2D array. Whereas if it is column major or C major, it will be, you'll be storing the items vertically. So first column will be your first element. Okay. So this is row major and column major. Please remember this thing. This is something you need to know. But this is again a conceptual storage of an array. Actual storage of an array is this. This is the storage of row major arrangement of an array, where the first row will be stored as first 4 members, next 4 members will be the next row, and last 4 members will be the last row. So here you can see this row is actually this row, this whole row. Okay, the second row. So what we'll do, we'll first store all the members of first row, then we'll start with the members of second. This way it does. This way it goes. Okay. So in this, what you can observe is just like a previous, if I'm just taking only this array, consider, don't consider rest of the part, consider this array. What is happening? This is the first element. After the first element, second is stored, then third is stored, and fourth is stored. Why we are doing it? I am repeating it. We are storing the array in a contiguous memory location because we are referencing them through addresses, through indices. So a continuous index will be there. With that index, we are going to access that. That is why this what we'll be knowing is only the address of first member. We'll be knowing only the address of base address of the array, and with that base address, we are going to access rest of the array. So if I'm talking only this 1D array, then this will be your base address. Adding 1 to it, plus adding one integer to it will give you the second first element, then second element, then third element. One integer is of 4 bytes. That's why it is jumping from 5000 to 5004 to 5008 and 5012. This maybe I am repeating several times, but I want this idea to be very clear in your minds. Now coming back again to the discussion, I realize all these things. Now here this row is the first member of 2D array. Just like for 1D array, first member is stored and then further. So what is the base address of this 2D array? Base address of this 2D array is 5000. That means this is the address of, I can say this is the address of ARR. This is the address of ARR, base address of ARR. It will also point to the 0th member of ARR. What is the 0th member of ARR? Row 1. 0th member of ARR is row 1. So it will be the base address of this array also. So what can I say is it will be the address of ARR 0. This will be also the address of this 5000. This is 5000. This will also be 5000. This will also be 5000. So again, I am repeating. This is the base address of a 2D array. This is the address of the first or 0th element of 2D array, and it will 0th element is an array. Okay, and it will also be the address of 0th individual element of a 2D array. So it will also be A of. It will also be the address of A of 0. Okay, so this has 3 roles to play. 5000 is the base address of this whole array. 5000 is the base address of the 0th element of this whole array, and it will be the address of 0th element of the 0th element of the whole array. Okay, so 5000 has 3 significances. Now, with the help of this 5000, with this, if I am adding 1 here, if I am saying I am adding 1 here, ARR plus 1, what will happen? If I am adding 1 in this case, what will happen? And if I am adding what will happen? Can you tell me what will happen? I am not talking in the terms of pointers right now. I am just making you explain these things. Don't mix up 2 things. So what will happen in this case? Array is a pointer. Pointer to it is pointing to the whole block of probably 12 into 4 bytes. That is 48 bytes. Okay, so it will be directly pointing to 5048. It will be directly implemented to 5048. Are you getting me? So the jump of 48 bytes, because this is a pointer to the 2D array. So it will take a jump of total block of 2D array. This will take a jump of 16 bytes because there are 4 integers. So it will be 5016. It will be pointing to 5016. And this will be pointing to, this will take a jump of 4. So 5004. So I hope you are understanding the differences in the jump or how the pointer will work. Now pointer ARR is actually ARR variable pointer ARR. If pointer ARR plus 0, then it is going to point to this, and it will be further. Okay, so this is the logical conceptual memory, and this is your actual physical memory. So this way, this is the first element of the array, this is the second element of array, this is the third element of array. Third element of 2D array. One element of 2D array is actually 1D array. So this will make the thing more clear. If I am talking ARR, that means ultimately ARR plus 0. So ARR plus 0, then it will point to the 0th element of array 2D array ARR. Okay, so it is going to point to the 0th element. What is the 0th element? Row 0. That is point towards 0th 1D array. This is itself, is a 1D array. Okay. ARR plus 1 will point to the first element, first 1D array. This will point to second 1D array. Okay. So this way it is actually pointing. So you can see the jump it is getting. It's getting jump of 16 bits each, because I'm talking about the entire. So ARR plus I will point to the ith element of an array. Okay, will point to the 1D array. 1D array, which is part of a 2D array. And then now how can access the further one? I hope the things are clear till now. If any doubts, you can ask now only. You can put your doubts in the chat box. I will go through that and try to answer that. Now again, since ARRI is the ith element of R, means ARR plus 1 will be the first element of ARR. ARR plus 2 will be the second element. ARR plus 0 will be the 0th element. So ARR plus I points to the ith element of an array. So on dereferencing it, it will get ith element of array, which is of course a 1D array. Okay, that's what we are continuously saying. So this will point to a 1D array. So what I can say is, thus pointer ARR plus 1 gives us the address of 1D array. This is not value at ARR plus 1. Okay, this is pointer variable ARR plus 1. So it is going to point to ith 1D array. So we know that ARR plus I is actually ARR plus I. This is a pointer notation. This is a conventional array notation. That is why what I can say is, this will also give the base address of 1D array, right? Which is of course points to the first element of array. First element of array is the array itself. That's why it is pointing to the base. This will return the base address, and this will also return the base address of ith row. To be very particular, star ARR plus 0 is actually ARR plus 0, which will be the base address of 0th 1D array. 0th 1D array. Ultimately, it will point to the 0th element of 0th 1D array. And similarly, address of first 1D array, address of second 1D array. Okay, so this way it is going to point. If I am taking just a small example of it. So ARR 0 will point here. So it will actually point to the base address of this array. Okay, and it also points to the base member, the first member of that array. Similarly, jth, kth element, these elements are there. which itself are in 1D array, and each will also be pointing to the zeroth element of that array. So this way an array is addressed. To generalize, asterisk a array plus I will be equal to ARR of I, which is base address of ith 1D array, which is zeroth element of ith 1D array. Zeroth element of what 1D array. Fine. Shall we proceed? Shall we proceed further?
Yes, sir.
Yes, sir.
These points need to
Yes,
be
sir.
made. Yeah, very good. These points need to be very clear to you people, because we'll be tomorrow we'll be having a quiz on this. We'll be having a quiz on this pointers. This is just an introductory discussion to our pointers. There are many more things to explore regarding pointers, and we'll be exploring it as and when we'll proceed further with functions, structures, and this kind of various kind of data structures. Pointers will be more uh, exposed to us, or we'll be getting more exposed to pointers. Now this is about, we are talking about addressing uh, 1D array in a 2D array. One 1D array in a 2D array. Now we need to be able to address one element in a 2D array with the help of pointers. So how we can, it's just a playing of indices or playing with addresses. What jump we'll have to maintain if I'm talking about accessing a single variable. Let us see here. If I wish to access this, it is the member of zeroth row, sorry, first row and first one. So this is actually Okay, fine. Actually, it got disconnected and PC got rebooted. So I think we are back on the screen and everything. So now we were discussing that how to address these individual elements. Okay, these individual elements. So if I'm talking about element number 6, it is a element which is located in the first column, first row. If it is, I'm talking about 11, it will be second row and second column. Okay, if I'm talking about 8, it will be first one, third column. So when I'm trying to access an individual element in an array, if I'm trying to access the number 11, um, I must be very clear that I need to skip these 10 elements, first 10 elements. Okay, 4 from first row, 4 from second row, and 2 from the first row, third row. In the other way, what I can say is I need to skip the 0th element of this 2D array. I need to skip the first element of 2D array, and I need to skip 2 elements from the second element of the 2D array. Okay, so I need to take a jump of 2 jumps of 1D array and 2 jumps of 1 element each. Okay, so this is what we are trying to do here. So what we'll do is simply uh, if array is initially pointing to this arrays, this is the base address, the 5000 is the base address. See here, uh, if 5000 is the base address, what I'll do, i'll add I'll add 4 integer bytes there. I'll again add 4 integer bytes so that I can skip 8 bytes, and then I'll take jump of small jumps of 2 bytes, and I can reach to this array. Okay, so to access the numbers individually, we need to decide what jump we are supposed to take if I'm using pointers to access an array. You may be having a simple question that, sir, this was okay, this was much easier when I was trying to access it using arrays. Why we are making it complicated by accessing through pointers? Because with pointers we are actually giving directly the address of that element, and because of that address, that element can be retrieved very fast. Whereas in the normal conventional way, that address need to be resolved, need to be referred, and then the elements will be accessed. Rather, uh, there are huge calculations involved into that. But as many programmers are not aware about the intricacies which happen in the back end of programming, they use the conventional methodologies and don't bother about the time and response time or compilation or execution time of the program. But as a programmer, I need to take care of that also. We will make sure that our program will execute finely and promptly and speedily. So for that purpose, we are making use of pointers, because this pointer will help you to directly address the um, that particular element than referencing it through number of different variables. That's why we are doing all these complications. So coming back to this, whenever I am planning to access individual element of 2D array, I need to be careful about calculating what are the array jumps we need to take and what are the element jumps we need to take. So what can we do here is, to access an individual element of a 2D array, we should be able to access jth element of ith 1D array. Okay, this first element of a second row, third element of first row, like that. So jth element of ith row. Row is what? Is a 1D array. So jth element of 1D array we are trying to access. Now since pointer arr plus I is an integer, and it contains the address of 0th element of ith 1D array. Okay, 0th element of ith 1D array. We can address the subsequent elements of ith 1D array by adding integer values here. So if I'm adding just 1 here, it will take me to the new element. If I'm, If I'm adding 2 here, it will take me to the second element, like here. If ARR plus I will represent the address of first element of ith will be, okay. First element, this is appeared first. First element of the ith 1D array. Likewise, if I am adding 2 into that, it will give me the second element of first 1D array. Okay. Thus, we can access individual elements. So, I can generalize this statement as ARR plus IJ will represent address of jth element of ith 1D array. Okay, jth element of ith 1D array. So, A of IJ can be accessed as pointer array plus I plus j. Ultimately, it is nothing but pointers plus I into number of columns plus j. So I is what? Is the jump of number of columns, jump of arrays, jump of whole array. So if it has 4 columns, then jump of 4. That is why I into is 1 into 4. So let us say that just take a small example. If I am trying to access 2, 3, value of 2, 3. Okay, in the previous case, whatever we have taken. So what is the value of PTR? 5,000. What's the value of I? 2. How many columns it has? It has 4 columns. And what will be value of J? 3. Okay, so it is nothing but 5,000 plus 8 plus 3. This way we can take a jump of it. Okay, so 3 means, so let us say that at what point it takes us? 5,000 plus I into 4. Okay, I into 4 is 8. 4 is the size of number of columns. Okay, so it will be 5,000 plus 8 into 4. What is this 4? Size of an integer. Okay, plus 3 into 4. So this is going to return with the address of 2/3 column. So 5,000, 8 into 4, 32, 3 into 4, 12, which is going to come out to be 44, 5,040. Okay. Address is 5,044. Let us say that A of 2, 3 resides there or not. A of 2, 3, 2, 3, 11. Okay, it is residing, 5,040. Should not be. It is at that element, so it should be 2. So it will be 0.24. Okay, so this way we can access the elements to of an array of 2 dimensions. So one by one we can access all this. Now coming to the next thing, it's already 11:46. Okay, we'll stop here today, and in the next lecture we'll see the pointer arithmetic, and later we'll appear for a quiz. So I need to finish this, so we'll do it in the next lecture. We'll stop here today. If you have any doubts, you can ask. Or if you don't have any doubts, you may be. You can do. Okay, the class is over.
So how we can print column 1
We
if we
can print.
want to print all elements of column 1?
No, every item need to be printed separately. Every element will put a loop just like we do in the normal array, and we'll implement it by one. Okay,
Okay.
so it cannot be like entire array is printed at once. In any case, for that matter, in C language, you can print only one element at a time.
Okay, sir.
सर अभी तक प्रैक्टिकल की बैचेस की लिस्ट नहीं है.
अरे हाँ यार मुझे मैं देता हूँ, मैं देता हूँ। Fine. Thank you very much.